Alright, so here we are with the 4-5 notes for Algebra 2. We're doing exponential applications. We're going to see how we can apply our exponential growth and decay here. So, when it comes to exponential growth or decay, we're looking at this formula, but b can either be from growth or decay. It can be a different value. So for growth, you're going to take 1 plus the rate, where r is your rate percent, but it's as a decimal. So for example, 4% would equal 0.04, because we're moving that decimal that would have existed back twice. Okay. So then we also have decay, and decay is actually going to be 1 minus the rate. Alright, and so it's just a little bit different of just having an A and a B, but we are talking about growth or decay. So in our example here, the value of a car is $21,500, and it loses 12% of its value every year. Well, loses means we're talking about decay. So, is this representative of growth or decay? Well, it's decay because of the word loses. And now we're going to write a function that represents it. So, if we have decay and it says its rate is 12%, remember that 12%, if we take that decimal and move it over twice, is going to equal 0.12. So that's going to be our R value. We also have the fact that it starts with an A value of 21,500, because remember that A is supposed to be the initial amount. And so if we plug it into our equation, or our function, we have a function in terms of x, where x is the number of years, and we start with 21,500, and then we multiply that by our decay rate, which is 1 minus 0.12, and then of course that is still raised to the x. Anytime that you write a formula, you always need your y or your f of x, and then your x in that final answer. So notice that we have the f of x and the x. We can, of course, rewrite this as well so that we do the subtraction of 1 minus 0.12. So you could rewrite it again as 21,500 times 0.88, because that would be 1 minus 0.12, and then to the x. So either way, you could have it with the subtraction already in it, or having done the subtraction. Alright, so then they want you to use the function to estimate the value of the car after 6 years. So that means that x is supposed to equal 6. So we're just trying to find f of 6. And so we plug in to the 21,500 and 0.88, but now it's to the 6. So how do we evaluate well, that? Well, PEMDAS says you do your power first. So 0.88 to the 6 is supposed to be 0.4644, a bunch of other decimals. And then we're going to multiply that by 21,500. And so we end up with, after 6 years, we're going to be at a value of 9,984. And since we're doing money, 0.69 cents. And again, it's a word problem, so value after 6 years. And I see now that I could put the value over here. Okay. So moving on, the next one, now they're saying use the function to estimate after how many years the car will be valued at 2,000. So now, instead of doing an x of 6, we're actually doing a y, or an f of x, of 2,000. So we need to solve when will 2,000 equal the equation. So you can, of course, do a guess and check and plug in, well, hopefully a number greater than 6, because we're trying to go down from to 2,000, and we started at 9,000. But of course, we're going to be doing our idea of solving here. So instead of 21,000 times 0.88 to the x, we can go ahead and divide out that multiplier, because we're doing SADMEP here. And so the order of operations says do addition and subtraction. We don't have any, so do division and multiplication because exponents would be after that. So 2,000 divided by 21,500 leaves us with 0.0930 and then 0.88 being brought to the x. And so this is in exponential format, but we're going to write it in logarithmic format to solve. So how do we change it to logarithmic? Well, remember that we have a log, and it's going to be the base of the thing that's being brought to a power, so 0.88. That's a terrible base. 0.88 there. Maybe I can write it. And then of the answer, so 0930, and that's going to equal x. So all we have to do is plug this into our calculator, log base 0.88, and that's under your math key, and then of 0.0930. And so we end up with 18.5781. And of course we're doing years, and so this 5 means that we'll probably round it to 19 years. Alright, so that is what you're going to be doing for an assignment today. You're going to be talking about rates of decay or growth. You're going to have a formula that you write, and then from that formula you're either going to plug in an x and solve, or plug in a y and solve. So this would be your assignment, and there are a few problems for that.